NENOMATICA, where mathematics meets YouTube excellence. Welcome to this lesson on polynomial multiplication. Today, we'll learn how to multiply polynomials using the distributive property and how to simplify expressions by combining like terms. Let's start with our first example. We want to multiply the expressions x squared plus x minus 2 and 3x squared minus 8x minus 7. To multiply these two expressions, we'll use the distributive property. The distributive property states that when multiplying a sum by an expression, we multiply each term of the sum by that expression and then add the products. Next, we'll multiply each term of the first polynomial by each term of the second polynomial. For the first term, x squared times 3x squared gives us 3x to the fourth. X squared times negative 8x gives us negative 8x cubed. And x squared times negative 7 gives us negative 7x squared. We continue this process for each term of the first polynomial. Now, we need to combine like terms. Like terms are terms that have the same variable raised to the same power. Let's collect all the terms with x to the fourth, then all terms with x cubed, and so on. Let's double check our work. The coefficient of x to the fourth is 3. For x cubed, we have negative 8 plus 3, which is negative 5. For x squared, we have negative 7 minus 8 minus 6, which is negative 21. For the x term, we have negative 7 plus 16, which is 9. And our constant term is 14. Now, let's look at our second example. We want to expand the square of a trinomial, a plus b plus c, all squared. To expand this expression, we'll first rewrite it as a product of two identical factors. By definition, a plus b plus c squared is equal to a plus b plus c times a plus b plus c. Now we'll use the distributive property again. We multiply each term of the first parenthesis by the entire second parenthesis. This gives us a times a plus b plus c times a plus b plus c times a plus b plus c. Next, we'll multiply each term inside the parentheses. For the first group, we get a times a, which is a squared, plus a times b, which is ab, plus a times c, which is ac. We continue this process for the other groups. Finally, we combine like terms. We have the squared terms, a squared, b squared, and c squared. Then we have the product terms. ab and ba are the same and equal to 2ab. Similarly, ac plus ca equals 2ac, and bc plus cb equals 2bc. So, we've shown that the square of a trinomial a plus b plus c squared equals a squared plus b squared plus c squared plus 2, a b plus 2, a c plus 2bc. This is a useful pattern to remember when squaring polynomials with more than two terms. We want to expand the expression x plus y cubed. First, let's rewrite this expression to make it easier to see what we're working with. The cube of x plus y means x plus y times x plus y times x plus y. To make this expansion easier, let's work on the first part within the brackets. We need to multiply x plus y by itself. Let's use the FOIL method, which stands for first, outer, inner, last. So we have first x times x, outer x times y, inner, y times x, and last, y times y. This gives us x squared plus x, y plus yx plus y squared. Now, we can simplify the expression inside the brackets. We get x squared plus xy plus yx plus y squared, all multiplied by x plus y. Note that xy and yx are the same thing, so we can rewrite it as x squared plus 2x, y plus y squared. Now we need to multiply this simplified expression by x plus y. We'll use the distributive property. We multiply each term inside the first bracket by each term in the second bracket. So we have x squared times x squared times y, 2xy times x, 2xy times y squared times x, and y squared times y. Let's simplify by performing each of these multiplications. We get x cubed plus x squared, y plus 2x squared, y plus 2x, y squared plus y squared x plus y cubed. Now, let's combine like terms. We have x squared y and 2x squared y, which gives us 3x squared y. Similarly, 2xy squared and y squared x combine to give 3xy squared. So our final expression is x cubed plus 3x squared y plus 3x y squared plus y cubed. This result follows a pattern known as the binomial theorem. For a binomial raised to the power n, the coefficients form what's known as Pascal's triangle. In our case with n equals 3, The coefficients are 1, 3, 3, and 1, which match row 3 of Pascal's triangle. Now, let's look at our second example. We want to expand the expression x plus y squared minus 4xy. First, let's expand the squared term. The square of x plus y can be written as x plus y times x plus y. Now, let's apply the FOIL method to expand this product. We get x squared plus xy plus yx plus y squared minus 4xy. Again, xy and yx are the same, so we can rewrite this as x squared plus 2x, y plus y squared minus 4xy. Let's combine like terms. We have 2xy minus 4xy, which simplifies to negative 2xy. So our result is x squared minus 2x, y plus y squared. Interestingly, this result is the difference of squares formula in reverse. The expression x squared minus 2x, y plus y squared can be rewritten as x minus y squared. So the original expression, x plus y squared minus 4xy, equals x minus y squared. We need to expand the expression 3 times the quantity 10 minus 4, y cubed, all squared. First, we need to understand what we're being asked to do. This expression has several components: a coefficient of 3, a binomial expression 10 minus 4 y cubed, and this binomial is squared. To expand this expression, we'll start by applying the square of a binomial formula. Remember, the square of a binomial follows the pattern. A minus b squared equals a squared minus 2ab plus b squared. So, let's apply this to our expression. We'll expand the term 10 minus 4, y cubed squared. Now, we need to distribute and multiply these binomials together. When multiplying two binomials, we use the distributive property to multiply each term of the first binomial by each term of the second. Let's multiply these terms. 10 times 10 is 100. 10 times negative 4, y cubed, is negative 40 y cubed. Negative 4, y cubed times 10 is negative 40 y cubed again. And negative 4 y cubed times negative 4 y cubed is positive 16 y to the 6th power. Next, we'll distribute the coefficient 3 to each term inside the parentheses. We use the distributive property, which states that a times the quantity b plus c equals a times b plus a times c. So, 3 times 100 is 300. 3 times negative 80 y cubed is negative 240 y cubed. 3 times 16 y to the 6th power is 48 y to the 6th power. Now, let's move on to our second example. Here's our second example. We need to expand the product of two binomials, the quantity x squared plus x minus 2 times the quantity 3x squared minus 8x minus 7. To expand this product, we'll use the distributive property repeatedly. We'll multiply each term in the first binomial by each term in the second binomial. Let's start by multiplying x squared from the first binomial with each term in the second binomial. X squared times 3x squared gives us 3x to the 4th power. X squared times negative 8x gives us negative 8x cubed. X squared times negative 7 gives us negative 7x squared. Next, let's multiply the second term of the first binomial, which is x, by each term in the second binomial. X times 3x squared gives us 3x cubed. X times negative 8x gives us negative 8x squared. X times negative 7 gives us negative 7x. Finally, we'll multiply the third term of the first binomial, which is negative 2, by each term in the second binomial. Negative 2 times 3x squared gives us negative 6x squared. Negative 2 times negative 8x gives us positive 16x. Negative 2 times negative 7 gives us positive 14. Now, we need to combine like terms to simplify our expression. Like terms are terms with the same variables raised to the same powers. We have 3x to the 4th power, with no other x to the 4th terms. 4x cubed terms, we have negative 8x cubed plus 3x cubed, which gives us negative 5x cubed. 4x squared terms, we have negative 7x squared, minus 8x squared, minus 6x squared, which gives us negative 21x squared. 4x terms, we have negative 7x plus 16x, which gives us 9x. And finally, we have a constant term of 14. We need to simplify the expression. 2x times the quantity x plus 3 plus 9, x times the quantity x minus 4. Our first step is to apply the distributive property to each term. Let's start with the first term, 2x times the quantity x plus 3. The distributive property tells us that a times the quantity b plus c is equal to a times b plus a times c. So for our first term, we have 2x distributed to each term inside the parentheses. This gives us 2x times x, which is 2x squared, plus 2x times 3, which is 6x. Now, let's multiply each term. 2x times x gives us 2x squared. 2x times 3 gives us 6x. 9x times x gives us 9x squared. And 9x times negative 4 gives us negative 36x. In our third step, we'll group like terms together. We have 2x squared and 9x squared, which are like terms because they have the same variable with the same exponent. Similarly, we have 6x and negative 36x, which are also like terms. Let's combine the like terms now. 2x squared plus 9x squared gives us 11x squared. 6x minus 36x gives us negative 30x. Now, let's move on to our second example. We need to simplify the expression, the quantity x plus 1 times the quantity x squared minus x plus 1. For this example, we're multiplying two binomials where one of them is actually a trinomial, having 3 terms. We'll apply the distributive property again. Each term in the first parenthesis gets multiplied by each term in the second parenthesis. So we have x times x squared, x times negative x times 1, 1 times x squared, 1 times negative x, and 1 times 1. Let's multiply each term. X times x squared is x cubed. X times negative x is negative x squared. X times 1 is x. 1 times x squared is x squared. 1 times negative x is negative x. And 1 times 1 is 1. Now let's group like terms. We have negative x squared and x squared, which are like terms. We also have x and negative x, which are like terms. Combining like terms, negative x squared plus x squared equals 0. X minus x also equals 0. This leaves us with x cubed plus 1. Therefore, our final answer is x cubed plus 1. Let's summarize what we've learned. When distributing, we multiply each term in the first expression by each term in the second expression. Then we combine like terms to simplify our result. This process helps us simplify complex algebraic expressions step by step. We have the expression 2 times open parenthesis, a minus b close parenthesis times a minus 3 times open parenthesis, a minus b close parenthesis times b plus 5ab. The first step is to apply the distributive property to expand the expression. We'll start by distributing 2 times a and negative b on the left, and then distributing 3 times a and negative b on the right. So we get 2 a times a plus 2 a times negative b minus 3 b times a minus 3 b times negative b plus 5ab. Next, we'll multiply the terms inside each bracket. 2 a times a equals 2 a squared. 2 a times negative b equals negative 2ab. 3b times it equals 3ab. And 3b times negative b equals negative 3b squared. We still have plus 5ab at the end. Now, let's rearrange the terms to group similar terms together. We have 2a squared minus 2a, b minus 3, a b plus 3b squared plus 5ab. Let's combine the like terms. We have negative 2ab minus 3, a b plus 5ab. Negative 2 minus 3 plus 5 equals 0. So the ab terms cancel out completely. And our final answer is 2a squared plus 3b squared. We can write this more concisely without the 0 term. Now, let's look at our second example. We have open parenthesis 2x minus 5, y close parenthesis times open parenthesis 4x squared plus 10xy plus 25y squared close parenthesis. Let's apply the distributive property again. We multiply each term in the first parenthesis by each term in the second parenthesis. First, 2x times 4x squared gives us 8x cubed. 2x times 10xy gives us 20x squared y. 2x times 25y squared gives us 50x y squared. Next, negative 5y times 4x squared gives us negative 20x squared y. Negative 5y times 10xy gives us negative 50x y squared. And negative 5y times 25y squared gives us negative 125y cubed. Now, let's group the like terms. We have 20x squared y and negative 20x squared y, which cancel out. We also have 50x y squared and negative 50x y squared, which also cancel out. That leaves us with 8x cubed and negative 125y cubed. Our final answer is 8x cubed minus 125y cubed. Again, we can write this more concisely by removing the zero terms. To summarize, we've seen how to expand algebraic expressions using the distributive property, how to multiply terms correctly, and how to combine like terms. These are fundamental skills in algebra that will help you simplify complex expressions efficiently. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.